and what sort of happened that resulted in you having to wind down this past
Oh,
week?
sure, yeah. Okay, so basically, I mean, our goal really was to just ship robots first and before anyone else. I wanted to be the first to market with a robot you could buy, and I think we did that. Best-selling American humanoid company even today. I don't know if anyone's ever like, it was just like my feeling was like, I started it because I was just really frustrated that I couldn't buy a robot, and, like, all these Chinese companies were just doing way better work, and, there didn't seem like a fundamental reason that a US company couldn't do the same thing. It just was like some quirk of the funding ecosystem. People, like, prioritizing demos over revenue, or, like, if you start to show revenue, then, people will, like, price, like, your company off of the sales rather than the potential.
Mhm, mhm,
Um, so
mhm.
basically, I just had this feeling, that we could do it, and, that was the mission. We basically, like, I mean, one thing that's, like, I was aware from the beginning it was, like, hard to raise money. I was like, "Well, we probably need to get some other milestone." So I started this kind of, like, side project at a hackathon. Is like, basically make a little mini humanoid that would be as cheap as possible. I got these, like, LX16 actuators off of Amazon. It was the same actuators that they use in that Columbia walking, course. It's like $100 to buy those actuators, and basically the goal was a hackathon project that, basically in the course of a hackathon, could you build a walking robot? And because we'd had all this tooling already for the bigger robot to, like, make it walk and get all, like, do all the kind of URDF exports flow, like, we could compress this Columbia course into a 24 or 48-hour grind. That was my
Wow,
goal, and it was
wow.
a cool learning experience. But anyway, I say this because then the idea kind of for doing that was that, I knew we had this big robot. I knew it was gonna be expensive to ship or whatever, but we probably need to get to revenue quickly, and I wanted to get this, like, small robot ready so that we could, have something out the door quickly. Like, the small robot would have been, like, way faster to actually get into customer hands, and you could 3D print it, like, it was way more accessible. Like, the total price was, like, a few $100 instead of being 8K. Um, and so, yeah, and then basically JX and Kelsey and Dennis sort of joined Kscale to just kind of, like, turn that into a real product. Again, living in the closets. And yeah, I mean, there was a bunch of, I mean, yeah, HR stuff. But I don't know. But yeah, they did a great job, and then we released it, and they, like, got, like, a decent amount of traction on. So they worked on it for, like, 4 months until, like, November. They launched it in November, and yeah, it got very viral on WeChat. The goal basically with this was, okay, we're gonna use this, like, smaller robot to fund the development of the bigger robot. Um, and that was kind of like how I thought it about it from a cash flow perspective. But then this VC guy that I greatly admire came by, and, like, I like was telling him about my fundraising issues, and he's like, "Oh, Ben, you just launched like 100, you get 100 orders for the Kbot, you'll be able to, like, raise money, no problem." And by raise money, he meant, like, raise like a $20 million, Series A. There's no one else that has this type of robot. So I was like, okay, we're gonna launch the Kbot. We'll just get as many orders as possible. Start hyping it up. Like, I think for my marketing strategy, I've always tried to be a little bit controversial. So, you start to create this kind of, like, competitive atmosphere with some other humanoid companies and get some attention, and then launch it. And I think that that's kind of like, for a company that's kind of done purely organic marketing, that felt like the right way to do it. Got some orders, and I think got some attention like we had intended. But yeah, I don't know, that just didn't work for VCs, I think. I think especially in Silicon Valley, a lot of the VCs I talked to were just too skeptical. The go-to-market for that product is gonna be very expensive. Like, we would need to do cast like, the plan was to basically take the current Kbot, go and redesign it for, like, die casting or cold forging or something that would be, make the unit economics work out. It's, like, literally what Unitree and all these other companies have done. Um, like, it was gonna take some more engineering effort, but, we launched it in July. Plan was to ship it in September or in November. I was, like, pretty sure I can, like, raise money. The VC that I talked to specifically told me, "You can raise money in a week." So I was like, "Okay, a week. Alright, I'll close the funding
Huh.
round, and then we'll start doing this. I think probably July was the wrong time to try to fundraise, but and then I basically was sticking with it for a couple months, without much success. We talked to a few CVCs that were like a few like these corporate people were really interested, but then like no, none of the Bay Area investors I talked to really wanted to invest. There were a few people that invested. I'm really grateful for them, but yeah, that was the situation. It was like, yeah, just like fundraising did not go as I planned, and I kind of had bet the farm on the Kbot launch, instead of the Zbot launch. Whereas I think if we had done the Zbot first, like, we could probably have gotten quite a few more orders because it's much cheaper. Like, we already had demonstrated, I think, that there was quite a bit of latent demand, and, like, yeah, it's just a much cheaper product to get to market, like, the regulatory approvals are way easier. The problem is then it would position as a toy company, and I want it to be, like, a serious humanoid company still. Um, but yeah, I would say, like, major missteps, like, that was probably number 1. I was over-indexing on how easy I thought it would be to get funding, and then, like, I got some advice on, like, the other stuff I should do, like, when fundraising was not going well. Probably not the greatest advice, yada, yada, yada. A bunch of people left, and yeah, that's kind of where I was like, well, at this point, I think, it doesn't really make sense to go continue with Kscale. This opportunity cost for robotics is really high right now. There's a lot of other stuff that feels more exciting.
So, Mara, we have the pleasure of speaking with Benjamin Bolt of Kscale, former CEO, I guess, of Kscale. This conversation is a little bit different than what we were expecting to have a few days ago. But Ben, is this like the first interview you've had since the wind down of Kscale?
Yeah, I don't do like a lot of like interviews, but
Okay, okay. Okay. And, well, instead of me announcing it, maybe you can sort of announce what has transpired over the past several days with Kscale, and maybe even turn the clock all the way back because there may be a lot of people who don't know that much
Mm.
about Kscale and your background. So, first, what's your
Oh,
background?
sure. Yeah, I go from the very start and then at the end. Yeah, I mean, so
Yeah.
I was a AI researcher at Meta for my start of my career. I think it's like fair Facebook AI research. Joined in 2018 to do like started out at Facebook and went into fair to do like speech representation research. It was like a
Mhm.
area of deep learning that was quite popular in like that time, like basically training from like unlabeled speech data to build representations that you could like learn from the structure, instead of trying to have some supervised learning problem for speech. Um, I was there for a couple of years, like 3 years, and then mid COVID, I went over to work at Tesla on the autopilot team, where I did some of the end to end training stuff for like the V11 update and um, built some CUDA kernels, try to solve meta problems at Tesla where best I could. Went back to Facebook when my wife and I moved to New York. Joined the robotics research team where I overlapped with
Mhm.
Chris Paxton, who is now kind of a big Twitter influencer, I guess, but he's yeah, yeah, yeah.
Well known.
Yeah, so
Yes.
Chris and
Yes.
I worked
Mhm.
together. I was only there for 8 months. I was in New York and Chris was in Pittsburgh, but, there's some other team members in the Bay Area, but, yeah, overall felt like it was not the right place to really do super impactful robotics work. I cranked out an IROS paper, and then, left to explore startups. Um, right after Meta, I actually was exploring a startup in the speech space doing, um, accent neutralization for call centers. Not my idea, but I, joined it was a CEO was, someone that I met through YC co-founder matching, and it was fun. It was like interesting. It was a good idea if you're trying to build a a speech business. It's like a good wedge, but I didn't wake up every morning like feeling super excited to be neutralizing accents, even though that was kind of related to some work that I'd done previously. Um, so I worked on that for 4 months. There was like some stuff that happened, and then I left that. and was just kind of sitting around unemployed. I liked messing with robot hardware. Was I had a in New York, I lived close to the Bronx, and I had this workshop in the Bronx where I had some 3D printers and just other tools that I could go mess with to build stuff. I liked messing with robots. There's a course at Columbia that's like it's like a semester long course where you build a walking robot, and they audited that course a bit, and found it was not that hard, at least to pick up some of the hardware stuff. And then just kind of like started thinking about what should I work on under the assumption, as with my previous startup, that the likelihood of failure was pretty high. Like, what could I spend, a couple of years potentially doing that would I would not be like, if it all went, topside lopside, I would still be, proud of the contribution that I made to the world. Whereas like, you know, I wasn't just kind of making Indian people sound like British people, but like, so that was kind of that was basically the philosophical like pool I was swimming in late 2023. Um, and yeah, I watched like YouTube videos with like one of them was from this guy Scientific who had reviewed this my actuator, like X8 actuator. That review got like crazy popular. I think for a lot of humanoid people, I know because I think the Botco also Botco guy also watched this same podcast, and he was like, everyone started using that actuator for random stuff. And so I was like, oh, well, and the actuator is pretty good, pretty cheap. I should just try to build a humanoid with it. I actually originally was going to go out to work at 1X because I helped refer like probably the first, like, 4 employees at 1X, were just referrals of mine to Eric, like, it's for the AI team, so I knew a bunch of people on that team. I was like, "Well, I wanna go mess with this stuff, maybe do some contracting." And then YC, like, there was a kind of a thing where, some I ended up doing YC. But that was a bit of a weird story too, like, it was like this guy wanted to apply, and I was coming off of not having like a great co-founder relationship with my former co-founder, and we applied, and then like I was like, I don't really want to do it with you, but then he like reached out to YC to go and try to do it on his own. And I was like, oh well, I might as well try to do it on my own too. And then they were like, well, I was like, I'd already left my job, and he hadn't, so they were like, oh sure, we'll fund you for that batch. So overall, it was like, it's kind of a random to do YC, I will say. But yeah, and then I was like, well, YC humanoid company is pretty cool. I'm sure that you can probably get some attention. Um, so, but again, I have no hardware background, so I was like, kind of approaching this tabula rasa. I had met a couple of weeks earlier this guy Matt Freed in at a hackathon in New York, who was like intro to me from a friend who, because Matt was building this orb that was like you could touch it and interact with a language model, but he was like a mechanical engineering by training, and so I was like, he was like basically the only mechanical engineer that I knew, so I was like, oh man, I should just go see if he wants to move to California with me and build a humanoid in 3 months because it was pretty cool, and he was also coming off of his thing at Malamute. um, and, sorry, this is kind of a rant, but I thought it was maybe interesting to give the full story. But anyway, so Matt and I basically moved into this hacker house in Palo Alto. I was originally paying him as, like, a contractor because, like, I was like, "Oh, yeah, you should just come do it for a bit, it'll be fun." And then we basically grinded on this for, like, um 14 to 16 hours a day for 3 months, and had a or for 2 months really, and we had the first version of, like, kind of the stompy robot, built and, like, designed and 3D printed, and, like, after that, and it was, I did not know Onshape before that. I did not know CAD. My CAD experience was basically OpenSCAD, which is, so I
Mhm,
was, like,
mhm.
totally going at this from truly tabula rasa. We got a bunch of those X8 actuators off of, AliExpress, and then a bunch of other sensors and stuff on Amazon. So, yeah, so overall, it was kind of like a challenge to myself to, like, prove that, like, there's, like, Figure and all these companies were raising all this money. I was like, "It's not that hard. I could probably do that." Like, that was my basic that was my basic instinct on how to do like, how to approach this stuff, so, and, I was, like, probably, like, felt felt like I'm a pretty good engineer and can figure out how to do this kinda stuff, um, and then, like but basically, like, after we designed it, we did a like oh, Robert Scoble did an interview with us that went kind of, like, viral. That was kind of the first thing that, like
Mhm.
yeah, I think that
Yep.
was the first thing a lot of
I
people
remember that.
saw, and that was pretty cool, and so basically, like, a bit before that, we were, like, just ruminating, I was like, "Hmm." If we can do this in like 2 months, and I literally didn't know anything about mechanical engineering before this, like, probably it's not, like, that terribly valuable. We should just open source it. Like, I'm sure, like, the marginal value of open sourcing it will be higher than the marginal value of keeping it closed source in this case. And then, that sort of, like, informed a lot of my basic thinking about just the company, business structure, all of this stuff was, like, we should um, you know, basically, there's really strong tailwinds for humanoids in China. Even at the time, this was before the G1 came out, but like I could just watch the ecosystem. There was all these great suppliers, my actuator and a few others, and now there's a lot more. It was just like,
Mhm.
well, strong tailwinds. I think that you can probably build a humanoid from components with like commercial off the shelf components rather than like needing to do a lot of stuff down to the bare metal. So and basically because I'm a software guy, I was like, well, that's probably ends up being pretty good because it commoditizes this hardware. The hardware will be commoditized. I'll be able to do cool software stuff. Um, you know, big asterisk over cool software stuff. But like broadly speaking, my feeling was the eventual goal would be to have like a Tesla style company where, the hardware is roughly commodity, and now I think Tesla's hardware, like car hardware, is pretty similar to like a lot of the others in the Chinese ecosystem, but you can drive value on the software layer and have high margins. So that was the extent of how I thought about it as a business problem. I think basically because I think it's weird because I think we ended up getting branded as like the open source company. I really tried to like I don't know. I think personally, open source is cool. Like I think I'm like the type of person that goes and moves into a house in Palo Alto and just grinds things out because I think I can do it. I think that's like a sort of spirit that resonates with a lot of other engineers in the open source community. And so I think we just were able to, yeah, like hit on a cultural theme and zeitgeist that was um, resonates with people. And yeah, I don't know. I think we had a pretty good job of like just kind of harnessing that. And it's cool. I mean, Bay Area is to me, the Bay Area is like the only place to do this kind of stuff just because like you just get a lot of that type of person that wants to come and contribute to this type of thing just because it's a really cool thing. And so even though, after YC we had like this 3D printed robot, at the time it was before the G1 came out. So I was like, I had a really hard time fundraising. I talked to all of the like probably like big name investors, and then they all kind of passed. But we were able to raise about $4 million, which and then I was like, well, I'm just gonna like push this through. I'm sure that I can get it to the point that we're selling a good product to customers, and then at that point we'll be able to raise more money. That was the broad feeling. And I was like, I just want to do this. This feels like the right thing. This is like the right time to be doing this type of business. And I think we have some insights that some of the other, really big players don't have. The problem is I think the problem with that also, I've been ranting for like 10 minutes, so please feel free to.
Don't
Okay,
worry,
yeah,
don't
I mean,
worry,
so
don't
so
worry.
the
It's
problem
interesting
with that, and
background.
if anyone's out there trying to raise money is like, um, yeah, it's like basically the thing is like when I was kind of doing this and a lot of investors were talking to me, this was right after Figure had raised like 600 plus $1 million. Um, the prevailing like consensus I think for a lot of people that I talked to was like, "Oh, you're too far behind." Like everyone's already like people already like raised all this money. They have prototypes that look really really great. And my view was basically that like you know, probably, like, this is not gonna be, like, the thing that really, I don't think there's gonna be a lot of differentiation for those companies in the end. Oh, also, like, Pi had just gotten together, and Pi was, like, doing basically foundation models for Chinese robots, and that felt like, and what like, the one brain for all robots idea was, like, a big thing, although, I don't know that that's panned out too well. But, and, there's a few other companies that were getting started around that time as well. But anyway, so I was like, and I think I'm just like a pretty stubborn person, so I was just gonna like push this through. So yeah, I went to China like kind of mid last year, met with a bunch of people in the hardware ecosystem. I have never been that I've never negotiated hardware deals with Chinese vendors, so I was like, it was very fun, good learning experience. I ended up hiring a very experienced product guy from, Xiaomi and Tencent and some other places that has quite a bit more experience with that, and, yeah, like, it just felt very necessary. My Chinese is not good enough to be able to negotiate these types of deals, although my mom lives in Beijing, for, like, the last 4 years, and I do speak some Chinese, so I actually think at least, like, again, my attitude has been like, I'm probably not the best at this, but I wanna, like, just do it and just try, and it's been a good prevailing sentiment. So, yeah, and then, we basically, like, we turned over the team a ton. I think in total there's been, like, 40 plus people that have worked at Kscale over the, 1.5 years of operations. It's been, and
Wow.
it's kind of like it's an open source
Yeah.
community. I think that's very much like the vibe. Like, we had this, we basically, after I moved out of the tiny Palo Alto place, I was like, well, I still want everyone to live in person. We're going to move into a bigger house. And the only place that had bigger houses was Atherton, which is this like very expensive neighborhood in Palo Alto. And I think like, so we basically got this Atherton mansion. Which was like expensive, but it was like awesome. Had a pool. It's a very good draw for like this type of, young hacker person. And I was just like, okay, anyone who wants to come, just come hang out. If you're cracked, I'll hire you, and we could just kind of build something awesome. Um, but, yeah, like, at one point, like, we had, like, 5 people in the basement with, like, barriers between beds. The basement is not a bedroom at all. We had, like, 2 pe like, there's 2 closets off the master bedroom in the upstairs, and we put beds in each of those closets. So, it was, like, very cramped space.
And
Yeah, yeah,
there
I'm
are
saying this now
zoning
because 'cause we've
laws,
moved
so
on, and I don't think we're allowed.
yeah, yeah.
Yeah.
Yeah, yeah, exactly, exactly. Because I've heard so much about the infamous hacker houses that I had to come
Yeah.
out and actually see one for once, and so I was out there last month and actually got to visit it, and it's
Yep.
not a hacker house, it's a maker mansion, and I was really kind of impressed with this. So much so that if you guys had offered me a
Yeah.
bedroom upstairs, I probably would have stayed. So just get an idea. So everyone knows. First, there's like a detached two-car garage, which is basically full of all these different 3D printers and stuff like that. So that's going on 24/7. And then there's an attached two-car garage, which is where you actually had like the teleoperation and putting it together so you could hang things from the ceiling a little bit better. And that's only a small part of the house. Then you get to the main house itself with like this huge family room where the cat is going on, a lot of other things going on. Also, living room, which is a great. I was looking at that place. Some companies would be lucky to have that amount of space to work in, and then the fact that the commute, you can't beat the commute. It's just
Yeah,
like
no,
walk down the
I'm really
stairs. That's
sold
it.
on this is the right way
Yeah,
to build a company if you're like a startup, but it's like it was expensive in the house
yeah,
itself because it's Atherton, but you end up in this situation where like the marginal person is pretty cheap because it's a good draw, and so it's like you have this very
yeah,
strong incentive to go and hire as many people as you can and just like cram them in, and like it's a good filter
yeah,
too
yeah,
for the
yeah,
right type
yeah.
of person. I found like the type of like especially being YC humanoid startup. I got a lot of people that applied were, like, kind of grifty people that just wanted to go, waste time and money. I personally, I'd never, like, run a company before, so I had not developed, like, a taste for what type of person I really wanted to hire or work with. And basically the prerequisite that if you wanna go work at Kscale was, like, you have to, like, sleep in a bedroom, or sleep in a closet, and work from, 10 AM to 3 AM every day. That filters out a lot of that filters for the type of person I like to work with. So it was, um, I just think is like, for a first time founder that like had never like kind of like I need to like get a muscle for this type of stuff. It was like, yeah, I think it was a good idea overall. And it was like a crash course in like how do you make a bunch of like 20-year-olds not, you know, just kind of spend time like aligning those like that kind of type of energy towards like a common goal is also I don't know, it's very 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 interesting. And that's I think that's basically where like the open source culture really kind of started to shine is like and having that kind of like you know, esprit de corps, I think is the phrase, but like that view of your like getting a bunch of people on board to do this kind of holy quest to go and like build an open source robot. I think that just yeah, I don't know, it really resonated. Um, I don't know if I'm like a cult leader, but basically that was my goal, I guess, was to build a cult.
Oh, yeah, I mean, yeah, it definitely had
Yeah,
the
totally, yeah.
mansion
It was
had
like, yeah,
Manson
Charles
vibes to me
Manson
when I
would have
was
been a
there
great
for sure.
startup
Yeah, no,
founder.
so no, but like you think about it, I mean, it's like, what are the struggles of acquiring talent and stuff like
Yeah.
that? The first thing is they gotta find a place to live, and that's a struggle in itself. And they find a place that's affordable, but it's a 30-minute commute, 30-minute, and then they find out it's actually like a 90-minute commute when you actually put cars on the road and everything else and all the stress and everything. So when you take that, it's a lot easier because I agree when you're doing a startup, you know, the focus is just something else. Just be able to not have to worry about all this other stuff that you could just go ahead and crank it out and get the right number. And again, sort of seeing what the team is like. So it was interesting to finally be able to experience that uh, in real life. So that was neat, as well as seeing the bot in real life. So can you just like quickly summarize what the K scale mission kind of was? And what sort of happened that resulted in you having to wind down this past
Oh,
week?
sure, yeah. Okay, so basically, I mean, our goal really was to just ship robots first and before anyone else. I wanted to be the first to market with a robot you could buy. And I think we did that. Best-selling American humanoid company even today. I don't know if anyone's ever like it was just like my feeling was like I started it because I was just really frustrated that I couldn't buy a robot and like all these Chinese companies were just doing way better work. And, you know, there didn't seem like a fundamental reason that a US company couldn't do the same thing. It just was like some quirk of the funding ecosystem. People like prioritizing demos over revenue, or like if you start to show revenue, then, you know, people will like price like your company off of the sales rather than the potential.
Mhm, mhm,
Um, so
mhm.
basically I just had this feeling, you know, that we could do it. And that was the mission. We basically like I mean, one thing that's like I was aware from the beginning it was like hard to raise money. You know, I was like, well, we probably need to get some other milestone. So I started this kind of like side project at a hackathon is like basically make a little mini humanoid that would be as cheap as possible. I got these like LX16 actuators off of Amazon. It was the same actuators that they use in that Columbia walking, you know, course. So you know, it's like $100 to buy those actuators, and like, and basically the goal was a hackathon project that basically in the course of a hackathon, could you build a walking robot? And because had all this tooling already for the bigger robot to like make it walk and get all like do all the kind of URDF exports flow, like, you know, we could compress this Columbia course into a 24 or 48 hour grind. That was my
Wow,
goal, and it's like it was
wow.
a cool learning experience. And basically, so I got these actuators. I was going to do it myself, but I you know I was doing other stuff. And JX, one of our employees who was extremely competitive, he was basically like, "Bro, I can do this. Like, dude, we're gonna wipe the floor with you." He was not an employee at the time. He was just hackathon. He was like, like kind of member of the community. He started getting really involved with Kscale and was like, and then he got this like guy Dennis and his girl Kelsey to come basically work with him. They were from Noisebridge, which is this SF um, like makerspace. Um, and basically they made a robot. They did it very well. Like basically Kelsey actually this is very interesting because again, not a mechanical engineer. Kelsey was a mechanical engineer. She really like broke down the problem in a different way from how I would have like to be able to prototype quickly. Like with these servos, essentially, you know, basically 3D printing like the chassis and then making sure that the servo fits into the chassis appropriately. And that like actually debugged a lot of this stuff. So they made a really good robot. Me and Matt also catted out a robot. Oh, Matt, then when JX challenged me, then Matt was like, I can't lose to JX. So it was a very competitive thing. Yeah. And so they actually made a robot that was able to, like, dab and do a little bit of walking, and we 3D printed a robot at least. Like, we designed a 3D printed robot, and it was fine. And then, basically they yeah, we did this, like, robot fight at the end of the hackathon, and it was pretty hot hype. But anyway, I say this because then the idea kind of for doing that was that, I knew we had this big robot. I knew it was gonna be expensive to ship or whatever, but we probably need to get to revenue quickly, and I wanted to get this, like, small robot ready so that we could, have something out the door quickly. Like, the small robot would have been, like, way faster to actually get into customer hands, and you could 3D print it, like, it was way more accessible. Like, the total price was, like, a few $100 instead of being 8K. Um, and so, yeah, and then basically JX and Kelsey and Dennis sort of joined, Kscale to just kind of, like, turn that into a real product, again, living in the closets. And, yeah, I mean, there was a bunch of yeah, HR stuff, but, I don't know, it was but yeah, they did a great job, and then we released it, and they, like, got, like, a decent amount of traction on so they worked on it for, like, 4 months until, like, November. They launched it in November, and, yeah, it got very viral on WeChat. I think the servo provider, the VTech servos were the servo that I had heard about from my friend Lincoln, who's, like, Red Rabbit Robotics, also very active on Twitter. He suggested these VTech servos to me, and I was like, "Okay, we should use it." Instead of the LX16s, those were, like, crappy. And so then basically, yeah, we used the servos to make a humanoid, and VTech has now, I think, become, like, the de facto servo for all these projects. Like, after we released ours and we did some pretty careful motor characterization, then the SO101 arm, like, started using them, and then the rest is history. So, yeah, I think, that was, like, a pretty cool experience where, like, kinda just, like, saw, like, the ability of open source projects to shape the ecosystem. Oh, and then we launched this product, and then this guy from China was a chief marketing officer or something at Dreamy Tech, the big robot vacuum company. He left to start a company to build robots, and he took that video and he started, like, showing it to a bunch of VCs, and he ended up raising, like, $40 million to build this type of humanoid. And then fast forward to, like, January, February, he, like, made this metal version, and we started doing this product launch. It was a catastrophe because it was very hard to work with that team. He was not a very technical person. We brought it back in-house, but the goal basically with this was, okay, we're gonna use this, like, smaller robot to fund the development of the bigger robot. Um, and, that was kind of like how I thought it about it from a cash flow perspective. But then this VC guy that I greatly admire came by, and, like, like, was telling him about my fundraising issues, and he's like, "Oh, Ben, you just launched, like, 100 you get 100 orders for the Kbot. You'll be able to, like, raise money, no problem." And by raise money, he meant, like, raise, like, a $20 million, Series A. There's no one else that has this type of robot. So I was like, "Okay, we're gonna launch the Kbot. We'll just get as many orders as possible, start hyping it up." Like, I think for my marketing strategy, I've always tried to be a little bit controversial. So, you start to create this kind of, like, competitive atmosphere with some other humanoid companies and get some attention, and then launch it. And I think that that's kind of like, for a company that's kind of done purely organic marketing, that felt like the right way to do it. Got some orders and I think got some attention like we had intended. Um, but yeah, I don't know, that just didn't work for VCs, I think. I think especially in Silicon Valley, a lot of the VCs I talked to were just too skeptical. The go-to-market for that product is gonna be very expensive. Like, we would need to do cast like, the plan was to basically take the current Kbot, go and redesign it for, like, die casting or cold forging or something that would be, make the unit economics work out. It's, like, literally what Unitree and all these other companies have done. Um, like, it was gonna take some more engineering effort, but, we launched it in July. Plan was to ship it in September or in November. I was, like, pretty sure I can, like, raise money. The VC that I talked to specifically told me, "You can raise money in a week." So I was like, "Okay, a week. Alright, I'll close the funding
Huh.
round, and then we'll start doing this." I think probably July was the wrong time to try to fundraise, but then I basically, like, was sticking with it for a couple months, without much success. We talked to a few CVCs that were, like, a few, like, these corporate people were really interested, but then, like, no, none of the Bay Area investors I talked to really wanted to invest. There were a few people that invested. I'm really grateful, for them, but, yeah, that was the situation. It was like, yeah, just like fundraising did not go as I planned, and I kind of had bet the farm on the Kbot launch, instead of the Zbot launch. Whereas I think if we had done the Zbot first, like, we could probably have gotten quite a few more orders because it's much cheaper. Like, we already had demonstrated, I think, that there was quite a bit of latent demand, and, like, yeah, it's just a much cheaper product to get to market, like, the regulatory approvals are way easier. The problem is then it would position as a toy company, and I want it to be, like, a serious humanoid company still. Um, but yeah, I would say, like, major missteps, like, that was probably number 1. I was over-indexing on how easy I thought it would be to get funding, and then, like, I got some advice on, like, the other stuff I should do, like, when fundraising was not going well. Probably not the greatest advice, yada, yada, yada. A bunch of people left, and yeah, that's kind of where I was like, well, at this point, I think, it doesn't really make sense to go continue with Kscale. This opportunity cost for robotics is really high right now. There's a lot of other stuff that feels more exciting, and the Chinese ecosystem is much more mature today, than it was when I got started. So, like, when I got started, literally, it's before the G1 came out. So the cheapest robot you could buy was 90K. Um, and so at that time, I think it made a lot more sense to make my own robot. And I think the sort of overarching philosophy made a lot of sense. Like, I think I still personally believe that there will be an open source humanoid that is a large percentage of market share for humanoids as a product category. Um, but Android kind of only came out after the iPhone, so maybe it's a bit early. I hope at some point, like, to probably revisit this. I mean, Pebbled was in the same way with their smartwatch. I think, like, they kinda got crushed early on um, by Samsung and Apple, but then now they're revisiting it because there is, like, demand for that type of kind of category of products. Um, and in the meantime, I think until it's, like, a little bit more mature, I'll probably go and do some other stuff. That was my general feeling. I mean, I will say, like, right now, I'm mostly decompressing from the last, like, year and a half of working, incredibly hard to get this thing done, learning a
Yep.
lot of stuff. I'll probably try to do something that I'm actually good at instead of something that I'm bad at. Um, so that's and I probably try to use my brain more, but that's where things are.
Okay. So, yeah, you could see a lot of things are happening out there that as you were starting to go in there was no established retail price yet for bots. There was speculation what they were. And like I say, the only ones you could buy were close to $100,000 and they were for researchers only kind of thing. And then the G1 came out and shocked everyone with like
Yeah.
16K. And it's like, oh my goodness, how can they do that for 16K? And they were actually selling quite a bit. Everyone was getting them. And then they come out and then they come out with another bot that's what now
Yeah.
$6,000. And then Engine AI responds and then Booster. And so suddenly it's like this race to the bottom of the price. And then you're probably thinking, well, yeah, I mean, maybe the appetite for these bots is around $20,000 or something like that. And already they
No,
were like, pull the
I will
rug
say,
out
I
from
really
underneath
think
there.
that, like,
Yeah.
at least, like, I kinda called it. I mean, this was, like, purely based off of I did napkin math for, like, where the bomb should end up, and I think most of that stuff has basically been true. My expectation personally, there's, like, 2 kind of routes that this can go, and, like, for humanoids is, like, consolidation or proliferation. It's like the 2 models here is, like, the DJI drone model or the, like, hoverboard model. Like hoverboard, like the self-balancing scooter. And, like, I'm actually, like, I think there's a pretty good chance that it'll end up being the hoverboard model because, like, there's a few things, like, the I don't know if you saw the recent Noetics robot. Yeah, I mean, the robot
Yes.
costs less than the
Hmm.
price of an iPhone. It's a different type of robot. It's not, 6 feet tall, but, like, um, that robot is not fundamentally very difficult to build, and at that price category, you're competing on margin in a way that, like, very similar to the drone market.
Yeah. Yeah.
I know
Yeah.
Noetics, I don't they're not doing a lot of, like, ML stuff that, you know, the average, like, kind of smart college student couldn't do. Um so, yeah, I think there's, like I would expect, like, for next year, there's gonna be, like, we're gonna flood the market with that type of product. And also, oh, then so basically, I mentioned that like Dreamy Tech guy, he's launching the similar product. The Shuo Yang is this ex Tesla engineer that went back to China to start this DJI style humanoid company that is launching a similar product. Like, there's a few pretty well funded like like mini robot companies that are now like competing on margin. I think we're gonna see like really really extreme, like, commoditization, and they're well funded enough, like, China still has enough enthusiasm for humanoids that, like, I don't know that the consolidation will happen as quickly as people might think, like, the DJI is, like, super consolidated because of only DJI. I think that's not gonna happen. So I'm actually super excited about what the next couple of years looks like. I mean, basically, it's we're gonna have this, like, once in a lifetime opportunity to, like, be part of the emergence of humanoid robots as a product category, basically like the PC transition for humanoids. So it's super exciting to me. I don't want to be like left out of it. And Yeah, maybe at some point, an open source version is the right thing to go back and revisit. I think I would say like the question I've been asking myself now is like, what does it take to actually make one of those robots like useful? Like where do you drive value for that type of robot? Um, and Anyway, yeah, that's a very interesting thing for me to think about, but I don't have like a super great answer yet.
I think the answer sort of what, Michael Cho has said, and that is they'll be funny before they're
Yeah,
useful. And that seems to be the case. And even yesterday in the Xipeng presentation, it kind of surprised me. He said, "Oh, we tried it in the factory and it doesn't work very well there. And we don't think it's safe enough to go in the home, and we don't have the AI for that. So it's going to go in the sales room. So basically it's
yeah.
going to be an entertainer." And he's almost saying the same thing is where the usability comes in there. And so there's still a lot of problems that have to be solved. And I almost wonder if making these like very tiny robots that are cheap that you get out there and people start experimenting and then people get the ideas of how do we scale it up, that they start getting safer and safer, is that almost the best place that if everyone can afford to have that in home, even if it can't do a whole lot, the fact that they can play around with it and experiment maybe will be an interesting way is to see the size going up rather than the
Yeah,
size
it's
going
weird.
down.
It's actually something that like when I was in YC, I was talking to like Emmett Shear about this humanoid thing. He was one of our group partners. And he was like, well, if you think the price of humanoids is going to go down so much, like, and the thing you're caring about is like solving physical AI, like there's going to be a world where you can just buy like a bunch of these mini robots and, just put some models on them and then get them to mess around and do stuff. Which is like probably, I mean, I wouldn't say, like, the right thing to do is, like, just get a warehouse and, like, have them fight each other or something necessarily, like, it's probably gonna be, like, messing around in your house or something, but yeah, like, it's gonna open a lot of doors, and it's gonna be, like, in the same way that, like, the PC commoditization of the PC created a lot more, like, computer programmers, there's gonna be a ton more, robot programmers because of that type of product. I'm very confident. And that's gonna totally
Yeah.
translate to making big
Yeah.
robots useful. I think that's, like, very obvious to me.
Right, right, right. And it could be that you get the sheer numbers out there and they can start to learn the physics that it's very hard to train inside a simulation because real world physics is very different. You just have to make sure you don't scale it down too small because if you get down really small, physics basically changes. That's suddenly what's not important for us. Like for insects, things like surface tension on liquids is extremely important, and there's a reason why they can do all sorts of things because they're just so small. And then when you get to a certain size bracket, then suddenly everything changes. So, but I would still think a desktop robot is going to be experiencing pretty much the same physics that we are, and it could potentially learn enough from there that, yeah, maybe it's then just a question of it getting a little bit bigger and moving up. So I always imagine the solution is like kind of going back to Douglas Adams' this idea, like open this warehouse door, and it's like an infinite warehouse full of monkeys in front of
Yeah.
typewriters, right? And it's really that's what we're trying to do is we need to have an infinite number of these bots just going out just playing, and eventually they'll all figure it out. They'll all like, write the collected works of Shakespeare, whatever. But in this case, it won't be typewriters. It'll be, I don't know, pouring glasses of milk and cleaning up spills and doing all
Yeah.
sorts of other things like
I
that.
think it might just be me because I've been doing AI stuff for, like, a decade, like, I don't think the AI thing is gonna be something that is gonna be exclusive purview of, like, Pi and Skilled or some of these, like, super well-funded companies, like, I think, like, robots are such a different thing from, like, training, uh, speech models, for example, or scaling LLMs, like, it's a like I remember my friend Vlad from 1X had this thing that says, like, most of machine learning is like the 90% of the work is this like data collection and infra, and then 10% of the work is the model architecture. But with robotics, it's like 99.9 to 1.1. Like the robotics like AI models are like I think it's pretty cool, but like you could probably look at any of these demos from some of these big companies and like they have some methodological sprinkles, but it's just like it's all infra. It's all the infra problem basically. And like getting a crap ton of robots out in the world as cheaply as possible. Like if everyone has a robot, you'll see. I think you're going to see like a lot of that, like the same kind of like stable diffusion type hacking on models. But for robots, I think it'll be a much more like powerful path to you know drive drive creation. Like I think that the stable diffusion model for robots is like much more likely to win than the stable diffusion model for image generation, where you can just scrape all the images on Google
Mhm.
Images. Yeah.
Yeah. Yeah. Mhm. Mhm. Okay. Okay. So I'm going to ask you some of my favorite questions. Now I know you don't consider yourself to be a mechanical engineer, but we'll go ahead and do that as well. Is that when it comes to designing a robot? So you've already built a robot a couple
Yeah.
of
A lot of
times, and you've had to think about this problem a lot. So from your perspective, the famous question is like, if you could add a joint for free anywhere in your robot, where would you add it? And I guess maybe do we use like the K scale
Mm.
as the baseline, or just like, the generic human bot, but or your generic kind of bot. But if you could add
Mhm.
one for free and that you just said, "Oh, it'd be really great to have," what is it?
I mean, okay, so for Kbot, there's like a lot of joints to add because it's really under actuated because we try to make it really cheap. But I
Mhm.
think for the Kbot, the one that is probably most comes to mind is like the hip like roll joint because it
Oh, you mean the abduction or the
abduction.
roll? Was it the leg roll? Yeah, let's look at
Oh,
this
that's
way.
great.
So is it this one, or is it
No,
like
so
the
lean left,
rotating
right.
back and forth?
Right.
Lean left,
No,
right.
I
Okay,
think
that's
the
abduction.
reason
Yep,
for that
that's
is because
abduction.
like, the gates are a lot easier to learn if you have that joint. Like, it's, like, a lot easier to,
Mhm.
like, learn a nice gate. Um, although, like, I mean, it's not impossible, but we had to, like, kind of, like, find, like, hack like, do a lot more reward hacking without it.
Okay, so yeah, so you yeah, and this is great because I've always kind of wondered, wrestling with that question myself, which is more important, that abduction
Yeah.
or the roll, the rotation. Now, obviously, the flexion, that's the most important. That's like numero uno. You can't take that away. You had the rotation in there, which seems to be important for being able to turn left to right. I always assume the abduction is really key. I mean, not just for like squatting and other things, but we're just looking at walking, maybe a little bit of balance. But you might be right, it's about the gait. But you know what abduction is really needed for? You're gonna love this one. If you wanna do the
Oh,
catwalk. So, the catwalk,
yeah.
because think about it, you gotta bring your legs in a little bit. So without abduction, you can't do it. Otherwise, your legs are just like going straight along like that. So that's interesting. I wasn't aware that you, didn't
Well,
have. I
that's
thought you
exactly that's
did you
exactly
put
the
it
point
back in,
actually is,
or
like, basically because the
yeah.
the human, like, joint like, hip joint is, like, way more centralized versus, like, all this, like, you have so basically, like, it's really hard like, the best robot gates kind of look like a catwalk. I think, and if you like, you basically end up swaying the torso a lot unless you can do some really specific RL stuff. Like, the RL policy needs to, like, be yeah, have some penalties to make the reward look kinda nice. So, like, basically, I think the holy grail for a humanoid robot design, in my opinion, is you can just, like, throw it into RL with a small number of rewards, and it learns a good gate. Like, the gate would be kind of like a
Yes,
prior of the
exactly.
design. And, like, that was actually my hope with, like, the pipeline that we built is we have this, simulation. Like basically, you CAD it at an Onshape, and then you can like run a script and like pull from Onshape into URDF, plop that into simulation, train a gate, and then like if you can get that like cadence down to maybe in a day you can make some changes in the URDF, then you could actually like maybe solve that design problem. Like that feels like at least the best forcing function for a great robot design is like, does it just learn how to like when you have a good gate, does it learn a good gate from a small number of words? Or put differently, I was really inspired by those like passive walkers, or essentially yeah, like the
Yeah,
passive
yeah, yeah.
walker design is like you're not actuating it at all. It learns this very like cool, smooth looking gate, and that's like a prior of the way you designed it. And yeah, and in that spirit, I was like, well, some of those decisions are like, the ankled off thing is kind of more for sensing, but is that really contributing it? So probably not accent. That was like basically like how I unpacked the problem myself. We never really got to the point where we were like actually iterating on it to that level. Just because like we spent a lot more time actually manufacturing it. Like going from your CAD model to manufacturing it is a huge challenge. But uh, that was
Yeah,
kind of my whole yeah.
yeah, yeah. And well, the other thing is that if you don't have the abduction, you don't really need to have the ankle
Yeah.
roll either. If you're on a flat surface, so you would never have that. So it's only and another when looking at all these different joints and whether you need them and how important they are, and of course, what the size of the torquing and the range of motion, it all comes down to what you plan on doing with it. If you just plan on walking straight on flat surfaces, you can minimize the number of degrees of freedom. But if you have to stoop down and squat and be able to get up from being fallen down or crawl, suddenly these other joints have importance that you never needed before for basic walking. And and that sort of limits you. So if you are coming up with these use cases, yes, we need some kind of locomotion, but we're talking about something really straightforward. Maybe you're able to get by with a forward off leg or something like that. It's you just yeah. Obviously, you need like the knee. The one of the reasons you need the knee is just to be able to climb stairs. And the other reason for the knee is to make sure that basically you don't trip. So you can lift your foot up during the swing motion to make sure it doesn't hit anything. But if you're on like a really flat surface, you can almost get away with that and just swing it through. But it becomes really hard to go upstairs. Just ask anyone who's got like a knee brace on, like, try going upstairs. It's like, wow, that's really hard. But you begin to realize the importance of some of these things, and that depending upon what the assumptions are, underlying assumptions, you can do that. And I do like your idea that the design should be, it's like the prior of what the gate is. And I'm not sure that we're designing our so-called humanoid legs to really be able to have a prior, which is a human style gait. Because as Chris Paxton, our friend, has said, is that robots are not made out of bones and they're not made out of muscle. They're completely different, and the actuation strategy is different. So, are we sure? And I suppose part of it is like, well, I'll design this bot, I'll put it into RL, and I want it to come up with the best one. And if it doesn't look at all like a human gait, I've got 2 things. One, I put a prior in that says it's gonna look like a human gait and give it to me, or it just tells me, it informs me, "You know what? You've designed it all wrong. You've got to redesign that thing." Yeah, that should be the feedback loop, is that if you are so intent to getting a gate that looks like that, then make sure your hardware fits it. And I'm not convinced that our hardware necessarily fits into that yet. I think there are some missing pieces there. So I'm glad you kind of brought that up. And for those who aren't sure what a passive walker is, basically you can make this thing that will just go down a slight ramp, and it will automatically locomote itself, and its legs will just kind of fall because it's basically a pendulum that's just able to swing through. So you don't actually need to give it any um well, the energy is basically come from potential energy from going down a ramp. You don't have to actuate it. So that means, and that's really what you want to do, is the human legs are designed that way, that we get a lot of locomotion just from the fact that it swings really well. The physics just helps us out there. Otherwise, we would not be as efficient as we are when it comes to walking. And we are extremely efficient walkers. I saw some posts the other day. You may have seen it as well, talking about how efficient humans are when they're on bicycles. And the whole idea is like, oh, we should be on wheels. And it's like, look at where we are. And somehow they were reading the graph as like, we were inefficient compared to like everything else out there. And I'm like, no, the way I'm reading that is like, we are one of the most efficient when it comes to it. And there is a reason we are, is because how did we used to hunt?
Oh
Do you
yeah,
remember?
I've read Born.
It's way before your day, but do you
Yeah,
remember
no,
how we used to
I
hunt, you
read
know?
Born to Run. I actually, I was,
Yeah,
like, very into the
yeah,
barefoot running
yeah,
thing and, like, the
yeah,
that's
yeah, yeah, but basically, it was like chasing, running the
yeah.
prey to exhaustion. We weren't as fast as them, but we were way more energy efficient that they would just drop from exhaustion. So humans are very good, and our gaits are very close to actually almost being a wheel, which is surprising. So, so yeah, I mean that's the thing. You probably get this question a lot. It's like, what are you doing even bothering about legs? What
Oh, of
about wheels?
course.
Come on, Ben. Is your next
Of
spot going to
course. I
be
mean,
wheel?
I feel like that's, like anytime you're trying to fundraise for a humanoid startup, it's like that's, like there's, like, a list of, like, probably a dozen questions that, like, everyone feels compelled to ask, and so I have to have, like, rehearsed answers,
Mhm.
although I try to, like, not say like, talk about those questions because they feel, like, low entropy. Like, I think my answer to the question is, like, reference whatever Elon has said. Anything that Elon hasn't have had an answer already, like, I can provide my own thoughts on it. I just don't yeah. Elon's views on bipeds versus wheels, I'll just go with that. Yeah, he's a smart guy. You can just reference him.
Mhm. Yeah, it's and so basically it's the same thing. It's the world is basically designed
Yeah,
for humans. It's much easier to get around in our spaces with legs and I think the other thing is point out, I like the way Oliver Stark kind of put it is that when people go down that wheel thing, it's like the only reason like wheeled vehicles are so efficient is because basically we terraform the whole planet for them. So I mean, if you think about it, wheels are a horrible idea if you don't have roads and everything. If you don't prepare the surfaces, forget your wheels being so great. But then again, I've seen some of the Unitree quadrupeds with wheels, and it's changed my mind on that
yeah.
because they're
Those
doing
are
some
pretty
pretty wild
sweet.
things in the middle of. So what it tells me is it's the problem with wheels is the fact that they're missing legs. It's really
Mhm.
a suspension problem. Without really good super active suspension, wheels will always get you in trouble. And I found that I think I've said this many times. I have a cart to be able to bring in all the water and stuff like that for the car to bring into the house. And then I've got to get over a couple of door jams. It's like impossible to get over the door jam. I was doing
Yeah.
everything throw my back out because the wheel's not big enough. And if you had like some sort of active suspension or something that would could just kind of go over it, it would be really. And that's what those quadrupeds do with the wheels isn't they come into some obstacle, it's like, oh, I'll just leap over it and then just kind of go on. So basically, it's just that their feet are wheels as opposed to it being a fully
Yeah,
wheeled
I think
vehicle.
on the wheeled versus legged thing, my only thing I would say is when I was a kid, I used to ride my bike, around in very dangerous situations. Like, I would, go out into traffic, and my mom would she hated it. And at one point, she said, "Ben, the next time you almost get hit by a car, I'm gonna make you, like, sit in a wheelchair for 24 hours, and you have to get around a wheelchair." And that's like and just so you know how, like, how bad it would be to have to, go around the world on a wheeled this is not what she said. I'm like adding my own commentary, but yeah, it's not fun to like have to be in a wheelchair. But actually, that might be an idea for someone if someone is interested in like mobility for like people that are around.
Yeah, yeah, yeah. Yeah, yeah, that's always been my feeling is that, the wheelchair is trying to be statically stable. So there's a lot of things about the wheeled width and everything else, and that's like one of the arguments for the wheeled vehicles is that, oh, they just won't fall over. The thing they don't realize is that they're actually way more tippy than people think, and it's really hard to be able to lean in and to adjust your balance real well. But I do like the idea of the wheelchair because everyone says, well, why not just have the? And it's like, go ahead and bring a wheelchair into your house, and then you'll see how difficult it actually is to get around your house without reorganizing it. So suddenly it has to be a lot wider. I mean, you've got to completely reconfigure your bathroom, like your bedroom. Oh, suddenly your bed can't be up so close next to the wall if you want to be able to get in there and fluff the pillows or do anything like that. And you begin to realize that, yeah, is that there are people who live in wheelchairs, and usually they are houses that are specially prepared for that, which gives you an idea of what's going on. I am hoping someday that there's like a rethink, and I know there's some people that are working on wheelchairs to not make them so wide and make them so low, and almost like having something like a Segway for a person that would be able to use it because that would make their accessibility a lot easier. And the other thing I like about that idea is that the one problem with the wheelchair is it puts people down very low and everyone else is up here. And so people are always looking down and they're always having to look up. And if you just find some way, it's like there's got to be a way of being able to boost people up, get that footprint down. But it's very difficult to do with something that is dynamic. You had to make it dynamically stable. And that's the problem with the humanoids that everyone is freaking out about. They're like, wow, these things are not dynamically they're dynamically stable, they're not statically stable. You turn the power off, bam, it goes. And then they say, and it doesn't have to be the power, just the power goes off. It's like one actuator burns out and suddenly it's going to fall over. Now, I don't know if this is necessarily the case. The elbow can burn out and I'm not going to fall over. Um, Maybe if the knee goes out, one of the knees goes out, I don't know. Is there some way the robot would be able to recover, or at least gracefully
Yeah.
fall down?
I don't know. There's, like, interesting ML ideas for that kinda thing, but, yeah, I don't have any great
Yeah.
answer personally.
Yeah. I mean, we're dynamically stable too, right? And it's just that I guess our mean time between failures is pretty high. It's, and right now the robots are not so good. I finally did the math on one of those, and I was like, because someone had mentioned this to me. It's like, oh yeah, I hadn't thought about that. That when you look at like the mean time between failure for a lot of robots, which is like, are the actuators, which is like 10,000 hours. That's about the best you're going to get right now. And if you've got 30 of those actuators, that doesn't mean your robot will go 14 months before it fails, running 24/7. It means you can expect your first failure within 333 hours, which is like within 2 weeks. Oh, really? And yeah, that's how it works. It turns out, and and so I double checked that with on Grok to make sure. It's like, yeah, because it doesn't mean that they're all guaranteed to last that long. You do have that curve.
Yeah.
It's a mean. It's an average of some sort. And by the time you look at that, there is that chance. And of course, the other thing is, what's the chances of the person who buys your bot using it in an off nominal situation? Be honest,
Yeah.
Ben. It's like, are they going to take it boxing? You think?
I mean,
It's so,
it's not gonna be screwing
yeah.
in lug bolts for 24 hours, that's for sure.
Yeah, 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 exactly, exactly. Well, even then, I mean, that was the interesting thing that the CEO of Xpeng says they were effectively doing that, screwing in lug bolts 24 hours, and they said they had to replace the hand within a month. And I was shocked. It's like, wait a minute, did I understand that right? Did they translate the Chinese correctly there? Because that is like an amazing statement. That I mean, I had a feeling there was going to be reliability issues that you would try to work out, but you would think just holding, and I guess just the vibrations and everything that's kind of going on there, that could be something that's harsh, and maybe there's some other operations that are a
I
lot
mean,
easier
I think
for it.
there's, like, so much value in just looking at what is working in China and figuring out how that maps onto stuff in the US. Like, the Chinese ecosystem is just very far ahead of the US, and so they've really, like, tried out a lot of these things. I think this is broadly why, like, for example, Figure has moved away from sort of their, industrial focus is, like, a lot of the Chinese companies actually shipped a bunch of robots to industrial customers, and mostly they were returned. UBTech had a similar experience with, like, the car manufacturing, stuff, so that's just, I think, how it goes.
Yeah. Now, speaking of UBTech, they recently showed their Walker 2, and it seems to be working more in packaging and warehousing situation. Because I think originally they were trying to get on the
Yeah.
on the automotive line, and that's probably a little bit
Well,
tougher.
they had a
And
big
it looks like they may
they had a
have
big
designed it
purchase order
more.
for automotive,
Yeah,
uh,
yeah.
I don't know if I think it was, like, BYD or something. It's, like, one of the big Chinese car manufacturers.
Oh, yeah. I'm trying to. It was. Is it one that begins with an X? I'm
It
trying to
wasn't it
remember.
wasn't, Xiaomi, it was I forgot.
'Cause Xiaomi makes their own bot, but yeah, there was one that I remember they're working with. The name
Yeah,
escapes me right now.
yeah, I think it was but anyway, they got returned because they weren't useful.
But supposedly they have a new order for some other location of which is basically
Yeah.
just moving boxes around. And I'm kind of wondering, is like, is it can they move boxes around? Agility is basically moving boxes around and do it 24/7 without difficulty because you don't have like the vibration that'd be coming from using a lug nut or like, the torque that's always coming on there. It's probably a bit more controlled. Your hands don't have to be that fancy. So you don't have to worry about that because that seemed to be what G Peng was saying was like, the hand was breaking before everything else. The and it seems like their walker, they designed it it's a very vanilla bot, but in many cases, it's like they almost design it with focus for a particular task, and maybe it's gonna be so that's what I'm keeping my eye on just to see how successful it is. Because if they don't get much success, then that's worrisome on whether there was something wrong with their bot design or it's just something wrong in the overall thesis of how well they're gonna be able to perform, because working in a factory is a lot harder than people probably
Yeah,
realize.
totally. I mean, one of the people that was in our kind of Discord for early on was this guy who was he runs like logistics out of for some Amazon warehouse, and he was really interested in like he told me a bunch of stuff about like some of the calisthenics stuff that they do for those guys. It's like warehouse work
Mhm.
is really wearing the human body. So
Yeah. 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 And they only have to do it for 8 hours, and 5 days a week. Okay. Only. And then you're hoping the robots will be able to do 3 shifts and do 7. So and of course, the other thing is that, I guess when we go home, supposedly, we recover and we heal and stuff like that. So we can do it the next day and the next day and the next day. Whereas the robots, unless they have a really good preventative maintenance program, there's going to be a lot of wear and tear. It's just not going to show up for a while, or will show up really quickly, and then you have to figure out how to. I guess one of the advantages of the humanoids is, in theory, they're very easy to swap out. Whereas with the industrial bots, you kinda had to either have the spare parts or you had to have, the spare bot that was not that easy to swap out because it's bolted down the ground and everything else, and you had all this other stuff to put on there. So it wasn't like it was a 5-minute job or 1-minute job. It usually might take a whole shift to be able to do something like that, or especially if it's a repair, then it's a lot more that's kinda going on, the whole line's down. With the humanoid, hopefully, it really is, "Oh, it's down, just
I
bring the
mean, I
next one
think,
in."
like, if we had gotten
And,
some funding and if we were to kind of keep pursuing the Kbot, my goal was to basically make the some of the limbs more immediately modular, like adding some standardized electrical interface between the arms and the torso and the head and the torso and legs and the torso, like, the idea of I think, it's like I don't know if you've watched Ex Machina, but there's this scene in the end where she like, after, she kills the guy and she breaks her arm, she, like, goes in, just, like, twists
mhm,
it off,
yep,
like, takes the other arm.
and then
That was,
puts the
like,
other
really cool
yeah,
to me.
yeah.
Like, that's just, like, if that you could, like, put that onto a real humanoid and, like, you know, it's just like your arm breaks, you can just go send it back. Um, if you're a business, it's great because you get to do this aftermarket sales. It's very parallels with how the automotive industry makes money. Um, and, yeah, you can kind of, like, just you can yeah, I think it's cool. I don't know why no one's done that. I think there's, like, some mechanical kind of issues like, that presents I mean, Unity kinda has that with their, like, the go-to, like, leg like, kinda collar thing, but humanoids are probably just bigger. I don't know. But I think it's a good idea. I think someone should do it.
Yeah, yeah, you probably wanna have a certain amount of, design for repair in them, but still, even if you can swap something out, like a new limb or an arm, it's not something that takes 10 seconds. So it's like, oh, we take that out, we throw another but it's nice to know that within the next hour, this one will be ready for when the next guy fails. So so at least you're able to kinda go through and do whatever the maintenance is, I agree. But again, sometimes this design for repair or design for maintenance is almost like an admission that you have a product which is going to fail often. And while it's very important in some designs, you have to realize at some point you wanna shift it over and say, we're not doing that anymore because we're designing for reliability and lifetime. And you have something in your pocket that does that right
Yeah.
now. So, that's your iPhone. You can't swap out the battery or do
Yeah, but
anything
it also
else.
goes to
Because the old days, you had to swap out the batteries because those things failed. Eventually, they get so reliable, and then people said, "Yeah, but now I keep on dropping my phone in my toilet." And it's like, well, in that case, you need to have it waterproof. And you want to have waterproof, we cannot make it so it's easy for you to open the thing up for repair. So, so you begin to see at some point, design for repair and easy maintenance is not necessarily something you want to design in. Uh, unless you're really talking about reconfiguration, reconfigurability, and then that's a
yeah.
different topic.
Okay.
Um, yeah, I don't know.
I think, for the time, I'm not sure, Ben, how many minutes left for
Yeah.
you?
I do have to probably run soon. That was a call for someone, but
Mhm.
yeah.
Okay. Okay. So maybe we would. Scott, if you have any question before you can,
No, no, I think this has been great. Always enjoy these chats, Ben. So,
Yeah, likewise.
and wishing you good luck in your future
Yeah, yeah.
endeavors. I'm sure our paths are
Thank you.
going to
Yeah.
cross
No, it's
again.
actually really, really great to talk to you guys. I think it's like I'm very excited about like humanoids kind of becoming cheaper, more accessible because I think it's going to be like I'm just very hopeful that there's going to be a lot more just discussion about right ways to do stuff. Like my view with Kscale really was like we wanted to take all of these like sort of trade secrets that are out there and just kind of like make it so that more people know them. Because then you just like all these like little details about the ins and outs of stuff like trade-offs like that stuff is what really like drives engineering forward. And so it's just cool to talk about this stuff. I love it. So,
Yeah, yeah, yeah. And that's sort of what I guess what
yeah.
I try to do as well is like look at what's going on and
I
explain
told you
why he's
before, we
doing
we
it.
referenced
It
your
it's
Twitter post all the time when we were
Yeah, yeah, yeah. So again, that's a little bit of the exchange of the information. I mean, everyone's open sourcing. As soon as it's a video, as far as I'm concerned, that's open source. The other thing I think is interesting that you were able to take a course on building a robot, and you think about like a decade or so ago. I mean, there was no course like that because no one even knew how to build a walking robot, and now we do, and we're teaching
oh,
in
yeah.
all schools, and that sort of
Yeah, that
shows that the
course is, it's
progress.
Hod Lipson's, Robot Studio course at Columbia. I
Yeah,
think they actually have some of the curriculum
uh-huh.
online. It's, like, pretty cool. If there's,
Yeah,
like, a starting point for building a
that's amazing.
humanoid, I think that would be it. It's, like, really cool.
Yeah, yeah, that's good. And now I'm crossing my fingers. I hope to see you maybe in about a month. I want to go out to the humanoid conference that's in uh,
Yeah.
mid-December out in the Bay Area. It's actually out in Mountain View. The only thing is, man, I don't know if the planes are going to be flying.
No, yeah.
Right now,
Those
it's
Epstein files. Really
uh,
the massive folders.
yeah, yeah, exactly. It's like until they get released, I
Really
don't know.
yeah, big liability for air traffic control, but yeah, anyway, yeah. Hopefully see you, yeah. Yeah,
Yeah,
great chatting.
yeah, yep.
Alright.
Okay, yep,
Bye.
yep. Bye, Ben.